Web crawling. In this lecture, I will cover web crawling introduction, SimHash, RankMass crawler, and the L neighbor crawler. Sorry, simplified crawler architecture. Suppose this is web and this is web index. Then how crawler work in between? Takes one documents, HTML documents, and then traverse the link, and then collects the newly crawled documents, check the near duplicate. If there is no duplicate entry, then it inserts into web index. If there is a duplicate entry, then it sends it to trash. So this is a very simple crawler architecture. Some issues with web crawling. Definition. First we will go through a definition of web crawler. Actually, web crawler is a program that browses World Wide Web in a methodical, automated manner or in an orderly fashion and extracts the specified number or size of links or pages. A web crawler is one type of bot or software agent. In general, it starts with a list of URLs to visit. This list is called seeds. For example, we want to calculate or crawl all pages related to neural networks, then we will use the neural network word as a seed word. As the crawler visits these URLs, it identifies all the hyperlinks in the page and adds them into the list of URLs to visit and call the crawl frontiers. URLs from the frontier are recursively visited according to the set of policies. For example, suppose I start with a seed word like artificial neural network. Then suppose we have a page that we get, and suppose this page contains some URLs 1, 2, 3 and so on. Then after visiting the page, we will have a list of all these URLs as a frontier list. Then we will start with this and collect the URL. In that case, we can also check the similarity with the content so that or we can continue. It depends upon our policy of crawling. The behavior of web crawler is the outcome of combination of policies. A selection policy that selects which pages to download, a revisit policy that it states when to check for changes to the pages, a politeness policy that states how to avoid overloading websites, and a personalization policy that states how to coordinate the distributed web crawlers. Now some important issues with web crawlers are duplicate pages, it creates problem, mirror sites, and identifying similar pages having similar content templates. It is tough to identify the templates. Deep wave, when to stop, it is also an important criteria or condition how to stop this crawler. Incremental crawler means here for example in this case, for every URL the crawler may get some list of pages, then it will get, after some time it will have a huge number of URLs that may be from diverse range of pages also. Refreshing policy, evolution of the web means a huge number of contents and quantity of web pages. Crawling the good pages first. Focused crawling, distributed crawlers, or crawler friendly web servers. Now I will go through the SimHash used to calculate the similarity between pages that we already crawled. For example, here in previous pages we check whether the page is duplicate or not duplicate. For that we can use this SimHash function. SimHash is an interesting and fast technique to calculate the similarity between two documents. For example, if we calculate the similarity between word by word matching of two documents, then it will take a lot of time. So instead of using that, we just converts the entire documents. We use the hash function to convert the entire document, and it will generate the just the hash number, hash key sorry known as hash key, and file name. So instead of comparing the whole documents just by using hash, comparing the hash key, it will work faster. SimHash is also useful because SimHash uses bitwise Hamming distance of two phrases to calculate the similarity between two phrases. If it's low, then Jaccard correlation coefficients between coefficients is high, means documents are more similar. Simple SimHash algorithm. Text is text is split into words, tokens. For each word, it generates a hash with common hash function. Weight are associated with words. The vector v is desired of desired length is initialized to 0. Means we cannot take very small words every time because it may be useless to compare with very small words. In the cycle, through all words hashes, vector v is updated. If ith bit of words hash is 0, the ith component is decreased by words weight. Otherwise, ith component of the vector is increased by word weight. The sign of components of v indicates the bit of final hash. By using this hash value, we can compare this hash value, and sign gives the final comparative results of SimHash function. This is taken from this paper. Now I will go through simple example of crawler like RankMass crawler. Actually, SimHash function is just used to calculate the similarity between two pages so that we can take decision whether to discard that page or to contain that page. RankMass crawler, it is a crawler with high personalized page rank coverage guarantee. Main motivation: impossible to download the entire web because it contains a huge number of pages. For example, many pages from one calendar. Other important question is when to stop or how to gain the most benefit from the pages we download. So main issues is crawler guarantee and crawler efficiency. Crawler guarantee means guarantee on how much of the important part of web we covered with minimum crawling effort, and if we don't see the pages, how do we know that how important they are? This is very important part. And now crawler efficiency: download the important pages early during the crawl and obtain with the minimum number of downloads. Means your entire download should contains the major percentage of important pages, and it should come in early download range. So we are going to formalize coverage metric. L neighbor crawling with L rank with rank mass guarantee, rank mass crawling to achieve high rank mass, windowed rank mass. How greedy do you want to be? So web coverage problem and personalized page rank. Some important points. Let D with a potentially infinite set of documents in the web. DC, the finite set of documents in our document collection. Assign important weight to each page. Page rank. Now page rank can be calculated for any given page by using this formula already assigned, and personalized page rank for any page can be calculated by using this scheme where Ti is known as personalization factor. Now rank mask. Actually rank mask use the personalized page rank that we formally define. Rank mask of any document in our collection can be calculated by using sum of their rank mask. Rank of their personalized page rank, and its convergence guaranteed. We seek a crawler that given rank mask uh, rank mask of page in our collected documents is always greater than 1 minus epsilon. Here this is used as a normalization, and it's used as a free constant, and its value may ranges from 0.1 to some very small value, or it depends upon the setting. Now rank mask crawler, some important issues. It is based on page rank. Then the question is how to compute the rank mask without downloading the entire web. We can't compute the exact, but we can compute the lower bound. This is the main feature behind the rank mask computation. So first what we do, we just identify the single trusted page. T1 is equal to 1, Ti is equal to 0, I not equal to 1. Always jump to page P1 when bored. We can place a lower bound on being within L or P1. This represents the lower bound of page P1. NLP1 page is reachable from P1 in L links. So this is single trusted page, and with single trusted page we reach the nearest page at level number of link is 1. When we increase the number of link to, then trusted page range will cover this many number of pages. At link number 3 it covers this range of pages, and so on. So rank mask crawler, some important issue. Lower bound guaranteed, single trusted. Theorem, this is theorem that we can assume that the trust vector T1, the sum of page rank values of all L neighbors of P1 is at least d to the power L plus 1, that is close to 1. That is, this is the lower bound guarantee, and this is the base of rank mask crawler. Now the theorem 2 is the rank mask of L neighbors of the group of all trusted pages G, NLG, is at least d to the power L plus 1, which is also close to 1, can be written as Pi member of NLG, where Ri is always greater than or equal to 1 minus d to the power L plus 1. These two theorems are the base of calculation of rank mass. So the lower bound for single trusted page can be given by this scheme, already discussed earlier. That is the basis of crawling algorithm with coverage guarantee. the L neighbor crawler. It starts with link is equal to 0 and 0 is equal to PIT. It starts with some trusted page, while here this is the one latest less than or equal to d to the power L plus 1. Download and uncrawled pages from nearest link NL and increase the link is equal to link plus 1. All pages linked to the page NL and then L is equal to L plus 1. Means this is like that. For example, it starts with here download all pages and L plus 1 stage means here, and then set L is equal to L plus 1. So now the node set will be like nodes at this link L is equal to 1 will be represented by P2, P3 and P4, and after that we will repeat this process. Some important issues. L neighbors similar to breadth first search. L neighbors simple and efficient. May wish to prioritize further certain neighborhood first, or page level prioritization to get more fine-grained page level priority. The idea is estimate page rank on a page basis, high priority for pages with a page estimate of page rank. We cannot calculate exact page rank. Calculate the page rank lower bound of undownloaded pages. For example here, so this is the click link, interrupted case, trusted page. These are the pages. Again interrupted, again we take in trusted page, and with this we continue. The probability of being at page P now can be calculated like that. So calculation of page rank lower bound. Page rank P is equal to probability of random surfer P, probability of random surfer in P. Break down path by interrupts. Jump to a trusted page. Sum of all paths that starts with an interrupt and end with P. This is interrupt and end with P. So sum of all the paths that starts with an interrupt and end with P. So these sums, such sums will give the page rank. Lower bound. Rank mass, the basic idea through simple so these are the techniques to calculate the page rank. Rank mass crawler, high level basic idea, dynamically update the lower bound on page rank, update total rank mass, download page with highest lower bound. Rank mass crawler, sorter, variables, CRM. Rank mass lower bound of crawled page, RMI represents the lower bound of page rank of PI. Rank mass crawler, CRM is equal to 0, RM is equal to 1 minus D to the power Ti into Ti, 1 minus D into Ti for each Ti greater than 0, while CRM less than 1 minus D. Pick up page P1 from the largest RMI, download PI if not downloaded yet. CRM is equal to CRM plus RMI for each PI linked to by PI, minus RM is equal to RMJ plus D by CI into RM. RMI is equal to 0. So this is simple crawler. Greedy versus simple. L never is simple. Rank mass is very greedy. Update expensive. Random mass to web graph, batching download together, updates together. So these are the similarities. Windowed rank mask, CRM rank mask, lower bound of crawl page, RMI lower bound of page rank of TI, RMI is equal to 1 minus D into TI for each TI greater than 0, while CRM is greater than 1 minus D. Download the top window percent pages according to RMI. For each page PI into DC, CR minus CRM is equal to, thus increase the value of CRM, and for each PJ linked to by PI, calculate the rank mass of added page and then put the RMI is equal to 0, and then repeat this process and then calculate the windowed rank mass of all downloaded pages. Thanks.